everyone, I'm Liang. Today I will introduce collision. Okay, we discuss collision in one dimension and two dimension. Okay, in one dimension, there are three situations. The light ball collides the heavy ball. The heavy ball collides the light ball. And two balls which are the same have a collision. Okay, at first we discuss, the light ball collides the heavy ball over the heavy. Because the heavy ball is like a wall to the light ball. So when the light ball collides the big ball almost doesn't move, and the light ball will rebounds. Okay, the heavy ball collides the light ball, what will happen? Okay, the light ball is nothing to the heavy ball. So the heavy ball collide nothing. So the light ball will gone. The heavy ball's velocity almost doesn't change. Okay, two balls which are the collision, what will happen? Two balls which are the same have a collision, what will happen? Okay, we assume that it's ball 1 and it's ball 2. The ball 2 at the beginning is stopped, and the ball 1 have the initial velocity. The ball 1 collides the ball 2, and at the moment, the ball 2 will have the velocity, and the ball 1 will stop, and the ball 2 will move, and its velocity is equal to the ball 1's initial velocity. Okay. Both of I said is in one dimension. Now let's talk about in two dimensions. In two dimensions, two balls which have a collision, and their moving path, and their moving path has an angle. The angle will be 90 degrees.
Hi, my name is Henry. Today I want to introduce to you one of the most famous structure in the history of architecture, the arch. As you can see, here is an arch. So, let me introduce to you. The weight comes down like this, and the structure of the arch can spread the force out like this. And when the force comes down to the bottom of the arch, it will become the force downward and the force outward. The outward force is cancelled out by the friction, and the downward force is cancelled out by the force upward provided by the ground. So, another key point of this structure is the keystone, is this one. As you can see, the keystone must be sloped like this to make the whole structure happen. And the structure of the arch is very stable. As you can see, when I put the mass on, the structure is standing still. So it's a quite genius and amazing invention by human. Thank you.
Hi, my name is Guanzhang Li. Now we want to introduce AFM. Everyone in junior high school must have used a microscope, and AFM is a kind of more sophisticated. The size of the atomic level can be observed. This concept is similar to the kind blind touch and element. In other words, it's like filling the surface with a mechanical probe. And this is our model. There are three structure composed this: probe, laser, and deflection sensor. We use this one as the probe to contact the surface, and the laser shine at the detector and reflect. When it's to do up and down, this represents the symbol's rough surface. In the end, the signal back to the computer. We can use this to make a diagram. Thank you.
Hi, my name is Jin Zhou. I want to introduce AFM. AFM's principle is using the interaction force between atoms. This first one is contact mode, which is contact with the sample surface when it's bent. It uses a depressing force. It can get better restoration but may damage the sample. The second one is no content more. It maintains a certain distance from the plot and the sample. It uses van der Waals force distance. Because before it's so small that we have to enhance signal strength, it doesn't decrease the sample force. The third one is tapering mode. It's between content and no content mode. It has both advantages.